Now we move to the quotient rule. And a quotient is when two terms have been divided. So a product is multiplied, quotient is divided. So you use it in something like this, where you have to derive a function of x, and unlike the ones we did the other day, you can't simplify that easily, if at all. And sometimes it's just easier to use this rule as opposed to simplifying it, and you have to make that call. So the rule is, if y equals u over v, so that's a quotient, then dy dx equals this thing here. Now if you look at this, the numerator is the same as the product rule the other day, except there's a minus there, not a plus. So it's vu dash minus uv dash all over v squared. So if you've got a fraction, you get a fraction as the derivative, and then you may be able to simplify it or not. It's crucial that it's in this order. Given there's a minus there, you're going to get the wrong answer if you switch them around. So please use it. Starts with a v. They both start with the v, denominator and numerator. So we're going to do an example. And this one says find the gradient of the tangent. It doesn't just say find the derivative, which we can do. It's one step further. Then find the gradient of the tangent at x equals 2. So that's when we sub in the value at that particular point and find that particular gradient. Let's see, that doesn't work. To get 16, so 21. So that's the derivative, and we're told that if x equals 2, m, which is your gradient, equals, and then we just sub it in, put lots of brackets there, 2 squared into 5 into 2 squared minus 16 by 2 minus 24 all over 5 by 2 squared minus 8 by 2 all squared. So it's 4 outside of 5 by 4 is 20 minus 32 minus 24 all over in brackets, that's 420 minus 16, and we've got to square all that. So it's 4 outside of 20 minus 32 is minus 12, so minus 36. Outside of 20 minus 16 is 4 squared is 16. We'll go this way. So we can cancel that. So it's minus 36 on 4. So the gradient of the tangent is minus 9 at the point x equals 2. And that's an example of the quotient rule.